where the highest power is squared. Okay, the highest power in that function is squared. Throughout this entire semester, you're going to have problems that ask you basically the same thing, but in different ways. It might ask you to find the solutions. It might ask you to solve. It might ask you to find the roots. It might ask you to find the zeros. Or it might ask you to find the x-intercepts. All of those phrases mean exactly the same thing. When you're solving for x, you're trying to find where that graph crosses the x-axis. Okay? Every one of these functions, every one of these equations is some kind of figure on a graph. Okay? It wants to know, where does it cross the x-axis? That's the solutions. That's the roots. Sometimes they call it the zeros or the x-intercepts. Okay? That all means the same thing. And so for all of these problems, when we're solving these equations, we're going to start off solving all these quadratic equations. Quadratic just means the highest power squared. When we're solving these, we're trying to find those points, those x values where it crosses, where that graph crosses the x-axis. Okay? And so a linear equation forms a line. Okay? The highest power in a linear equation is 1. So you don't have any x squareds or to the third power, to the fourth power. Okay? And that forms a line. And a line, how many places can a line cross the x-axis? No, just a straight line. It can only cross it one time. That line never bends. It can't come back. Okay? Unless it lays directly on top of the x-axis. Okay? In that case, it crosses it at every single point. Okay? A quadratic, it curves. It's a parabola. Okay? It curves one time. So it can cross the x-axis at one point, which means that the curve barely just touches the x-axis. Okay? So it only touches it at one point. Or it can touch it at 2 points, as in this case right here. Or it can touch it in no points. If this graph was like this, it wouldn't touch the x-axis at all. And in that case, it still has solutions. It still has those, but they're imaginary solutions. So if it never touches the x-axis, we call that imaginary solutions. Okay? And we'll get into imaginary numbers in a little bit. Okay, so a linear equation only has one solution. A quadratic equation usually has 2. Sometimes it only has 1. Yes. Here's some methods for solving a quadratic equation. We're not learning all these methods today. We're only doing the first method, solving using square roots. We only use this when there isn't an x term, meaning there's an x squared term, but there's no x term. So if it's x squared equals 16, we can use the square root method. If it's x squared minus 25 equals 0, we can use the square root method. Okay? If there's a x squared plus 2x equals 16, can't use this method. It won't work. Okay? So today we're going to be using the square root method. The second way is solving using completing the square. That'll come in a couple of days. Okay? The third method is solving using the quadratic formula. Everybody knows what the quadratic formula is, right? Okay. Quadratic formula can actually be used anytime. Quadratic formula can be used for any quadratic equation. That's an automatic. You can go to that. If you don't know how to do it, you can automatically go to the quadratic formula. It works for every single equation. If you're missing the x term, as in these two examples up here, okay, quadratic formula, you need a, b, and c, right, to be able to plug it in to the quadratic formula. We'll talk about that later, but if you don't have, in this case, we have a, but we don't have b, right? So you could put a placeholder. You could let b be 0, okay, if you wanted to use the quadratic formula for it. But today we're just talking about solving using square roots. So if you're missing the x term, if you have the x squared term, but you're missing the x term, you should automatically go to this method. I have a pair of 2's. So that means a 2 can come out of the radical on the outside. So that's equal to 2. I don't have a pair with 5, so it stays under. So the square root of 20 simplifies to 2 square roots of 5. Anybody know why I can take that 2 out? Why?
It's a square root, so you're looking for 2 numbers of the same.
Yes, because 2 times 2 is what? 4. What's the square root of 4? 2. Okay? So anytime you have the square root of something squared, it's just itself. So this is the square root of 2 squared, which is just 2. Does that make sense? So anytime you have a pair, it can come out, but the reason why it can come out is because it's that number squared. So the square root of something squared is just going forwards and then going back again. Okay? And so the square root of 27 will do the same thing with it. So 27, if I break that down, 9 times 3, 3 is prime. So it's the end of that piece. And then I can break 9 down into 3 times 3. Okay? So the square root of 27 can be written as the square root of 3 times 3 times 3. After we do that, we circle our pairs, because that's going to tell me what I can take out. So I can take out a 3, but I still have 1 left underneath. So the square root of 27 is the same thing as 3 times the square root of 3. And you could always check that in your calculator. If you put in the square root of 27, it's going to give you some decimal number. And if you put in 3 times the square root of 3, it better be the same decimal number. So you could check yourself. As you work these problems in your homework, you can go check and make sure whatever you simplify it to, if you simplify anything, it better be exactly the same as what you started with. So anytime they say simplify, your answer should equal what you started with. Okay? Any questions so far? Okay, square root of 72, we're going to do the same thing with it. 72 is what times what? So we have 9 times 8. Am I done with either of these? No, right? They can go further, so I'm not circling anything yet, okay? So 8 is 4 times 2. I'm done with 2, right? But I'm not done with 4. 4 is 2 times 2. Now I'm done with that side. Okay? And so 9 is 3 times 3, and I'm done with that. So the square root of 72, you always want to put it in numerical order. So start with your lower ones and go to your higher ones. These are factors, okay? These are factors. When I multiply them, I get back what I started with. So the factors of 72 are 2 times 2 times 2 times 3 times 3. So this is the square root of 2 times 2 times 2 times 3 times 3. Okay? Don't leave anything out. Okay? So, next I need to circle my pairs. I have a pair of 2's and a pair of 3's. Okay? So I'm going to have a 2 that's going to come out, and I'm going to have a 3 that's going to come out. And left underneath there is going to be my 2, right? So I have square root of 2 that's left underneath the radical, and then I have 2 times 3, which goes on the outside. So you multiply those on the outside, those factors that you pulled out. So that's 6 square roots of 2. And 6 times the square root of 2 is the same thing as square root of 72. If you put those in your calculator, you get the same answers for both of them. 6 square roots of 2 is just simplified. Okay, so square root of 30 is our next example, number 4. Square root of 30, if I take 30 and I break it down, I get 10 times 3, right? And then if I break down 10, I get 5 times 2. Do I have any pairs?
No.
I don't have any pairs. So square root of 30 can't be simplified. It is already simplified. So all you do is you just leave it, square root of 30. Okay, it can't be simplified anymore. You have to have a pair to be able to take out for it to change. Now, when you have a square root times a square root, you multiply the inside with the inside and the outside with the outside, okay? Because these are all factors. This is 4 times the square root of 3 times 2 times the square root of 21. The operation between 4 and the square root of 3 is multiplication. It's 4 times the square root of 3. So when you have a bunch of things multiplied together, they can all be shifted around, okay? And so you multiply the inside with the inside. So square root of 3 times the square root of 12 is the square root of, what's 12 times 3? 36. What's the square root of 36? 6. We don't need to do a factor tree for that one because 36 is a perfect square. So if it's a perfect square, don't waste your time. 36 is a perfect square because 6 times 6 is 36. 49 is a perfect square because 7 times 7 is 49. 81 is a perfect square because 9 times 9 is 81. So when I say a perfect square, it's because when you can break it down into something times itself, that makes it a perfect square. Okay? And if you take your calculator and you put the square root of 36 and it equals a whole number, that's how you know that's a perfect square. Okay? Now, for this problem, number 6, we multiply the outside with the outside. So that's 8. And then 3 times 21. So it's the square root of 63. Okay? Now I need to simplify the square root of 63 because 63 is not a perfect square. So when I take 63, I break it down into my factor tree. So that's 9 times 7. 7 is a prime number, so I circle it. And then 9 is 3 times 3. Okay? So the square root of 63 can be broken down into, so don't forget the 8. 8 times the square root of 3 times 3 times 7. Okay? Now my pairs, I have a pair of 3s. They get to come out, right? So what am I going to do with that 3 that I take out? Very good. I'm going to multiply it times that 8. So that's 8 times 3 times the square root of 7. And then simplify that. So it's 24 times the square root of 7. Okay? Any questions? Not too bad, right? Okay. Okay. Now, had this simplified to, say, 2 square roots of 3, okay, say that wasn't the square root of 27, say it was square root of 12, and it would be 2 square roots of 3, you can reduce the 2 things that are outside, you can reduce those like regular fractions, okay? Now, in this case, we can't. You can't take something that's outside of the radical and reduce it with something that's inside the radical because this is protected. Okay? It's protected, so you can't do anything with it. This 3 underneath the radical, you can't do anything with it. You can't reduce it, you can't change it. It has to stay what it is. But if they're outside, then that's just like 3/4. Okay? So if that was a fraction that you were able to reduce, you would do that. Okay? Any questions? Yes.
What if you get a square root in the denominator that's not a perfect square?
Okay, that's exactly like our next problem. Okay? You cannot leave a square root in the denominator. Your answer cannot have a square root in the bottom. Okay? And so what we need to do to remove the square root, you rationalize the denominator by multiplying by 1 in the form of a radical. Now, what does that mean? That sounds all complicated, but it's really not. Okay? If I multiply anything by 1, I don't change it, right? I don't change it. If I multiply by 1, it stays the same. Okay? Do you also agree that anything divided by itself is equal to 1? Right? So if I take a fraction and I multiply it times 4/4, that's still multiplying it by 1, right? Or if I take a fraction and I multiply it times 10/10, that's still multiplying it by 1. Agreed? So if I take a fraction and I multiply it times the square root of 2 over the square root of 2, that's still multiplying it by 1, because I'm multiplying it by something over itself, which is still 1. Do you agree? Okay, so this is called rationalizing the denominator. If you take any square root and multiply it times itself, the square root goes away. Square root of 2 times the square root of 2 is equal to the square root of 4, which is 2. The square root of 3 times the square root of 3 is the square root of 9, which is 3. The square root of 4 times the square root of 4 is the square root of 16, which is 4. So, if you take any square root and multiply it times itself, the radical disappears. That's ultimately what ends up happening. And so, to get rid of a square root in the denominator, okay, we know that when we take a fraction underneath the radical, we can break it apart into 2 separate square roots. That's square root of 7 over the square root of 2. Okay? Now, because we have the square root in the bottom, we can't leave it like that. And a lot of times your answer will end up like this, and you have to fix it. And the way that we fix it, the way that we get rid of this square root, is we multiply it by the same exact thing. Because when I take the square root of 2 and multiply it by the square root of 2, I'm going to get the square root of 4, which is 2, right? But what you do to the bottom, you have to do to the top, because I don't want to change this fraction. I'm just altering it. I'm just manipulating it. That's all I'm doing. So if I don't want to change it, I have to multiply the top by the same thing, because that way I'm taking this and multiplying it by 1. Right? Because then that doesn't change it. Okay? So now, what I end up with, square root of 2 times the square root of 2 is just 2, right? And on the top, that's the square root of 14, okay? And the square root of 14 can't be simplified anymore, okay? So this is my answer. Square root of 14 divided by 2, if you put that in your calculator, that will be exactly the same thing as square root of 7 over 2. These two things better be equal. If they're not, you did something wrong. Okay? So that's called rationalizing the denominator. Okay? Tangents work the same way. So we have the square root of 5 over the square root of 3. Y'all try this one. Try that one. Okay, let's see how you did. Okay, so we need to multiply the top and bottom by what? Very good. Square root of 3. By the square root of 3. Okay, so I end up with the square root of 15 over 3. How'd we do? Good? Good. Okay. Okay, we're going to stop there for today. So for your homework, you have to do page 267, 20 through 50 even. 20 through 50 even. Okay, so you want to write that down. Page 267. Through 50 even.